privilege of hearing from some of our colleagues in Europe. The first speaker is from Arianespace, and that will be Jean-Yves Gall. Morning.
So good morning, Mr. Chairman. Good morning, ladies and gentlemen. First of all, I would like to thank this August Commission for allowing me to address your committee as it considers issues of historical importance to the continued exploration of space. As you said, my name is Jean-Yves Gall, and I am the Chairman and CEO of Arianespace. Our company, Arianespace, is the first commercial launch service provider in the world. Our first mission was 30 years ago, and our latest mission was 30 days ago, with TerreStar-1, the biggest commercial telecommunication satellite ever launched. TerreStar-1 was nearly 7 metric tons, and we launched it to geostationary orbit. But even bigger than TerreStar-1 was the first ATV launch last year when Arianespace hit a milestone and put the 19.4 metric ton ATV Jules Verne into low Earth orbit. After the ATV made its picture-perfect docking with the ISS 2 weeks later, members of the crew were able to bring aboard several tons of crucial supplies and equipment. Shortly after that, the ATV raised the altitude of the ISS, and it also did the unexpected in using its thrusters to slow down the ISS to avoid orbital debris. In the meantime, the ATV served as an extra room for the station. Its pressurized interior allowed the crew to use it almost as if it were another module of the ISS. This ATV launch was a major step forward that enabled the international partners to fully utilize the ISS to conduct important biological and scientific research in space. Now, we are looking for 2010, when we launch the second ATV named Johannes Kepler to the ISS, in support of a completed ISS with a full crew of 6 astronauts. We, at Arianespace, are very, very proud of the flawless ATV mission controlled by your colleagues at ESA and CNES. And with all due modesty, we were equally proud of the launch vehicle that put the ATV in orbit. The Ariane 5 has now been in operation for more than a decade, and since inception, the Ariane 5 has proven itself to be a reliable heavy-lift launcher. Originally human-rated, the Ariane 5 has adapted to its present-day role as a leading large-capacity launch vehicle for satellite operators and international partners the world over. But the Ariane 5 is not limited, as you know, to GTO launches. As I will point out in my presentation, the Ariane 5 can reach lunar orbit, the lunar surface, and Mars, objectives that are compatible with NASA exploration mission. We often tell our customers that launches speak louder than words. Let me say that launches also speak louder than PowerPoint slides. We are a proven solution for providing cargo to the ISS, and I am here today to provide a short presentation on this topic. Now, please allow me to elaborate on these points. So you have here some slides. I would like to get the next slide, please. Next. Okay, so first of all, a few words on the mission. Today, as I said, with the Ariane 5 and the ATV, we provide cargo services to the ISS through appropriate international collaboration in support of NASA's human spaceflight activities. Next. As you know, the baseline for the ISS utilization is first to support for 6-person crew aboard the completed ISS, the ISS utilization for biological and scientific research, and in 2010, the shuttle retirement will diminish the US upmass return capability until CRS supplier come online. So CRS, it has 4 independent parts, 2 launch vehicles, and 2 cargo systems, which must be operational by 2011. And the requirement for 20 missions carrying 48 metric tons of cargo between 2010 and 2015. So we see that NASA is likely to need gap filler commercial cargo service by 2013, should any of the 4 systems be delayed. And I think that there is likely a shortfall of 8 to 12 metric tons per year in 2012-2015. Next. A few words about our company, Arianespace. Since 1980, we placed space in the center of everyday life with launches for science, for Earth monitoring, for security, and of course for communications. And since our inception, we launched a total of more than 50% of operational commercial satellites. And as I said, the last one was TerraStar 1 in early July. Next. In our mission, in fact, we are committed to organize everything around the launch. And in particular, for the servicing of the station, we have now in our order book 6 Ariane 5 launches devoted to launch VATVs. The first one has been launched last year, as I said, and the next one will be launched starting next year at a pace of 1 every 18 months. Next. Ariane 5, today this is probably the most reliable heavy lift launcher. We have now, since 2003, 31 successes in a row. We have a capability of 20 metric tons to low Earth orbit. It was the ATV mission. A capability also to lunar transfer orbit and to Mars. And this point is quite important because I think that Ariane 5 is a very well-suited launch vehicle for the exploration. We have a very good launch tempo with a total of 7 launches per year. And today we have 46 launch vehicles which are currently in production. Now, a few words about the VATV Jules Verne. Next. At launch, we had a total mass of 19.4 tons. And the Jules Verne has a capability to bring 840 kilo of water and 100 kilo of air to the station, 4.7 metric ton of propellant for ISS reboost, some 0.4 metric ton for disposal mass, and globally, VATV has 3 times the capability of a Progress launch vehicle. Next. A few words about the mission overview. The Jules Verne arrived in French Guiana, our home port, in August 2007. We performed the launch last year on the 9th of March. We docked it to the ISS on the 3rd of April. There were some reboost firings on April 25 and June 20, and the mission lasted in September with the induct from ISS and the atmosphere re-enter. Next. You have here a comparison between the VATV, the Progress, and VHTV, and you see that for the cargo mass, we have a capability with the VATV of 7.75 metric ton. The cargo, as you know, is 3.2, and the VHTV, which will be launched for the first time by our Japanese colleagues next month, in fact, is just 6 tons. Now, a few words about the international cooperation. We are performing our launches next from the Guyana Space Center. There are 2 points on which I would like to insist. We have very modern facilities meeting all Western safety standards, and this is in fact a NATO territory, which is also quite important for the launch of governmental satellites. Our next very important mission, besides VATV, will be the launch of the James Webb Space Telescope, and we are very honored to have been awarded this contract by NASA and ESA. and it will be an heritage from Rosetta and Herschel Planck that we launched early this year. As a conclusion, next, I would like to say that I think that the Ariane 5 ATV cargo resupply can provide gap filler services until CRS providers fully meet NASA requirements. This is the first point. The second point on which I would like to insist is that this approach can sustain architecture for future US human spaceflight, providing utilization of the completed ISS. The third point, Ariane 5 ATV is a flight-proven system, and I think that it is quite important because it is now fully available with Ariane 5, 31 successes in a row, and the perfect flight of the Jules Verne last year. And this available system, this flight-proven system, meets NASA's ISS cargo resupply requirements. And last but not least, I think that this is a very nice opportunity for international collaboration using a successfully demonstrated capability. I thank you for your attention.
Thank you very much. We do have time for questions. Jeff, would you like to start?
Yeah, thank you very much for the presentation. I have to ask this one very carefully so we don't say too much or too little. The ISS experience has demonstrated quite clearly that it's very advantageous to the robustness and sustainability of your program if you have more than one way of doing things, because then when one of them has a problem or has a slip or has an accident, you're not down to zero. I'm also aware that when you ask any commercial supplier, can you do fill in the blank, the answer is always, well, yes, if I have enough money. So I have to ask you to distinguish in this question between that which is sort of a reasonable stretch beyond where we are today and that which, of course, anything can be done for the right amount of money. We're faced with the task of looking at an array of launch vehicles. Some of these launch vehicles have more capability or more throw weight than others. It sure would be nice if we designed exploration elements and other launch providers could launch them, because then there'd always be more than one way to launch them. So within the bounds of reasonable sanity, how big can you go in the future?
See, as I said in my presentation, what is important for me, in my opinion, is that this system, Ariane 5 plus ATV, is fully available. And with Ariane 5, every 2 months, we demonstrate the reliability. And the ATV, we have a first flight which fully demonstrated the capability of the system. So it's almost an off-the-shelf system. And I think that this is a point which is the most important. Now, in front of us, we have plenty of Ariane 5 launches for commercial purpose. And it will be very easy to pick one of these launchers to be used for VATV. This is basically the reason why we plan to have 6 ATVs launches for ESA within the frame of the barter agreement between NASA and ESA. And we guarantee the reliability of the launch with Ariane 5 because of the successful commercial exploitation of Ariane 5. So I think that this is a fully available system, flight proven, and after this, we can, if a decision is taken to use the VATV for flights outside of the barter agreement, we need 36-month clearance for VATVs, and for Ariane 5, we have plenty of launchers which are ready to use.
Leroy?
Yeah, it's not really, sorry, we didn't, that's all good information and I'm very much interested in it, but that's not quite the question. The question is, what larger throw weight derivatives of the Ariane 5 can you reasonably foresee being developable over the next 5 to 6 years that might provide a backup or an alternative path to US source launchers for elements that are larger than the ATV or HTV?
Today, Ariane 5 to launch the ATV is using its full capacity, which is about 20 metric tons in low Earth orbit. There are some plans to increase this capacity, but the decisions have to be taken in the next 2 or 3 years, and it will not be available before, let us say, the end of the next decade. Today, we have a system working with Ariane 5 and VATV. For the rest, there are decisions to be taken, and of course, there are, after this, to demonstrate that the system will be flight-proven.
Leroy?
Well, thank you for your presentation and for coming all this way to meet with us, and congratulations on the string of successes of Ariane 5. My question is about Ariane 5. I'm sure there have been some studies done. Can you comment on the qualitative difficulty of human rating an Ariane 5, and was the Ariane 5 perhaps designed with that thought in mind?
Today, at the beginning, Ariane 5 has been human-rated, and after this, you know the story, the Hermes spaceplane has been cancelled, and now the vehicle is no longer human-rated. So if it should be considered to launch with Ariane space astronauts, which may be a strategic objective for space, we will need to once again qualify Ariane 5 to be human-rated. Today, this is not clearly in the plans of Europe. This is an objective, but it is not yet decided. And what we are focused on the VATV launches. We have 6 launches in front of us, and we started recently a study on the possibility to have a cargo return capability.
If one were to order an Ariane 5 today, how long would it be before one could launch it?
With Ariane 5 today, I missed your point. Could you repeat?
I'm interested in the lead time between an order and on orbit.
For Ariane 5, it is not a problem because we have plenty of vehicles which are ordered. The question is for VATV, and for VATV, we consider that the order has to be made 36 months before the launch.
I'm sorry, how much?
36 months, 3 years for VATV. But for the Ariane 5, as I said, we have 46 launch vehicles which are in production, and we have plenty of launch vehicles which are available.
Any other questions? Bo, do you have a question by chance? All right, Sally?
Yes, I actually do have one, Norm. Thank you. I'm curious about your plans for evolution of the ATV. I think I heard you mention that you're thinking about it as a possible return capsule, cargo return capsule. I wonder if you could describe the timeline for that, when you would expect that to be tested, and whether you plan to consider evolving the ATV beyond that, perhaps for a rescue capsule from the space station.
She was asking about the return capability of an ATV and what the timelines were for that, and an associated rescue capsule capability.
There is now a study which has been started by the European Space Agency about the return capability of the ATV in changing the upper part of the ATV. I do not know the exact figures because the study are just starting, but this could lead to a decision in 2011-2012.
Well, thank you so much for sharing your thoughts with us. We appreciate your coming all this way.
Thank you.
Thank you.